This lesson is going to be on diffusion and dilution. So, in terms of kinetic theory, we're going to first look at diffusion and Brownian motion. Now, as you can see here, there's a little starter question from the previous lesson. What is the difference between evaporation and boiling? Now, the answer is that evaporation can occur at any temperature, obviously above zero, whereas boiling occurs at the particular boiling point of the substance. So evaporation is when only some of the particles near the top of the liquid have enough energy to escape and overcome the forces, whereas boiling is when all the particles have enough energy to overcome the force of attraction between the particles. Now, in the next slide, we'll look at Brownian motion and essentially what is kinetic theory. So these are the questions you need to think about. Do particles move constantly or do they stay still? Now, we've already discussed it, and the solid particles are always vibrating. How does temperature affect particle speed? And what else can affect particle speed? So these are the main points. Kinetic theory states that everything is made of tiny particles that are constantly moving. And the word Brownian motion means the constant random movement of tiny particles caused by collisions with air particles or water particles. So when the particles collide with the air, they might bounce off and move in a random motion. That's what Brownian motion is. Now, all matter is made of tiny, invisible moving particles, which move at all times. The higher the temperature, the more energy they gain, so they move faster. And if particles are heavier or have a higher MR, which you'll learn about in the calculations topic, they will move more slowly than if they were lighter. Now, diffusion is defined as the spontaneous movement of gas or solid particles from a higher concentration to a lower concentration until they're equal. So if you spray some deodorant here on this side of the room, the particles will diffuse from where there's a high concentration, where I've just sprayed, to the other side of the room, where there's a lower concentration. And just like an air freshener as well, that would then spread out throughout the room until it's equal. Now, we can see a diffusion experiment here. You put hydrochloric acid on one end, and you soak some cotton wool in some concentrated hydrochloric acid. On the other end, you soak some cotton wool in ammonia solution, and you leave them. What tends to happen is that the hydrochloric acid particles and ammonia particles will evaporate and diffuse across from a high to a low concentration. So they will diffuse towards each other. If they're to collide together, ammonia plus hydrochloric acid, they will make ammonium chloride, which is a white solid. Now, if you notice, the white solid has formed closer to the HCl end. The reason for this is due to the speed of the particles being different. The acid particles must have moved slower than the ammonia particles, which makes them heavier. This is the explanation. So ammonia particles are lighter and evaporate from the cotton wool and move faster by diffusion through the air. And the collision with the HCl particles, the hydrochloric acid or hydrogen chloride, will happen closer to that end. So the white solid is closer to the hydrochloric acid end. If you imagine you had a very fast sprinter, Usain Bolt, at the ammonia solution end, and you were on the other end, if you both start running towards each other at the same time, then obviously the faster sprinter will get closer to you, would have traveled the further distance in the same amount of time. Okay. When they meet a white smoke, ammonium chloride forms. And these are the key points. Ammonia particles are lighter and move faster. Now, diffusion in liquids is slower than in gases because the particles in the liquid will move more slowly, because there's less gaps, there's small gaps between the liquid particles for the diffusion to occur. So as a result, the diffusion is slower. They also have a lower energy. Now, before we look at dilution, I just want to show you one other type of notes on this, one other experiment. So here you have diffusion. So bromine gas is filled in one jar and then an empty jar of air, and you have a plate between them. When you remove the plate, the bromine gas will diffuse upwards into where there's a lower concentration from a higher concentration until they're an equal shade of brown. Roughly takes 5 minutes. So the air and bromine particles moving randomly with large gaps between the particles. Now you can also have diffusion in a liquid. So if you have some potassium manganate crystals in water, that has been a common exam question. What happens over time is that the potassium manganate diffuses from a high concentration to a lower concentration. So therefore, it'll gradually get less kind of purple at the bottom and more purple towards the top. And that will gradually occur. And after 4 hours, the equilibrium is reached. We will cover equilibrium in a different lesson, but that's when there'll be an equal shade throughout the whole thing. So the concentration of particles have been evenly spread out, just like with the air freshener, just like with the bromine gas. So we've already talked about this. And this is the diffusion in liquids being slower because the particles are more closely packed. So this experiment took 4 hours. This experiment took 5 minutes, okay? That's one of the factors that affect it. What medium is a diffusion in? So in air, it's faster. In liquids, it's slower. Last thing we talk about is dilution. So first of all, what is dilution? Let's have a look here. So dilution or a diluted solution contains only a few particles of the solid, and in a concentrated solution, there's much more of the solid and less of the liquid, the solvent. That's actually one of the next lessons. We're going to talk about all the S words, such as solute, solvent, saturated. But we briefly mention it here. A solution is saturated when you cannot dissolve any more solute into it, unless, of course, you heat it. That completes this part. Now, just to check these notes as well, here we have potassium manganate crystals are dissolved in water. The solution can be diluted several times. So what that means is, if I dissolve these crystals in this volume of water, and if I pour a bit of it in here, after the 4 hours have passed, I'll pour a bit here, then it's going to have some sort of shade of purple. But if I add more water to it, I'm going to dilute it, and then it will therefore become lighter in color. So that's the key point. If you dilute something and it has color, it will slowly fade more. So the color fades but does not disappear until lots of dilutions have been done. So just like if you're making squash or Ribena, you put some squash and you put water. The more water you add, the more diluted it is. The explanation is, so in here, this indicated there's a lot of particles and a small amount of potassium manganate, and therefore the particles must be very, very small. Right, so we've looked at diffusion, which is when these particles spread through the water. Don't confuse it. Dilution is when you simply add more water. Okay, but diffusion is how the manganate essentially dissolves, by diffusing from a high concentration to a low concentration. Okay, that brings to an end this lesson. And the next lesson is going to be on, I believe, the separate elements, compounds, and mixtures, and then separating techniques. That's what we have to do. So in fact, next lesson, we're going to look at those S words, and we're going to look at solubility curves. And then afterwards is the elements, compounds, mixtures, and separating techniques. Thank you for listening, and I will see you next lesson